All right, here's section 6.1, continuing our thoughts on solving systems of equations. Now we've talked about what systems are briefly, but we'll get into detail with that. And then also we've talked about how we can write equations from real life situations. And now we're going to take a step back and once we get those equations, how can we solve them? So that's what today's section is about. Your goal or objective for today is to solve systems of equations by graphing. So the first method I'm going to teach you is graphing. All right. So with that, we have a couple of vocabulary terms. First one is, well, what is a system of linear equations? A system of linear equation is simply two or more linear equations together. We're just going to deal with two equations together, um, but that's what a system of linear equations is. And what about a solution to a system? Kind of like just one equation, the solution would be whatever variable or variable numbers would go in for the variable or variables in the equation to make it true. Well, like that, a solution to a system of equations would be an ordered pair, meaning you get one x and one y that work to make both equations true. All right, oftentimes there'll just be one x and one y that would make them true. And there's actually three different methods for solving systems of linear equations. Um, you see right here, we have the graphing method, we have the substitution method, and we have the elimination method. So I want to give you as many options as you can for solving these, and we're going to start with the graphing method today. All right, so you got to remember how to graph. Salamander! All right, so what is the solution to the system of equations to the right? Now you might notice that there's two equations here. That means it's a system of linear equations. They're both linear equations, things that we worked with last chapter. And they're actually both in slope-intercept form, the y equals mx plus b form. All right, so how do we do this? Well, let's graph them. Let's graph each equation on the same graph. That's what we're going to start by doing. So y equals x plus 2, that would be y equals 1x plus 2. Now remember, when it's in this form, it's great because the b would be our y-intercept, which is also where you start. And the m is the slope, which is your rise and your run, because that tells you where to go. Rise this many and run that many. Okay? And that makes the graph of the line. So let's graph the first one. We'll do the first one in blue. Y equals 1x plus 2. Remember, 2 is the y-intercept. And that kind of looks like a b, which is, I mean, it's the letter b, but it's the y-intercept. So on the y-axis, it starts at 2. 1, 2. And the slope is 1. So that one right there. The b is 2. The slope is 1, or 1 over 1. As a fraction, it would be 1 over 1. So that means you rise 1, and you run 1. There you go. Rise 1 and run 1. Just keep doing that, and that will make your line. All right, let's do the second one in purple. This one's a little bit different because there's a minus sign. Take note of that. So the b would be negative 2. That's just where you start at negative 2, down 2 right there on the y-axis. And the slope, or the rise over run, is 3, or 3 over 1. So I'm going to go, whoops, up 3, 1, 2, 3, and over 1. Up 3, 1, 2, 3, and over 1. Up 3, 1, 2, 3, and over 1. And I have this lovely graph of this line. Now the question is, this is great. We graph both of them. Boom. Might think we're done, but it says what is the solution? So that's what order pair x and y would work for both equations. In this case, we have them graphed, so let's look at what order pair would work for both lines, and there's actually only one. It's where they cross. That's the only ordered pair that would be on both lines, and that's the ordered pair 2, and then 1, 2, 3, 4, 2 and 4. So that is the solution. 2 and 4 would be 2, 4 would be our solution. That's the x and the y that works. All right, so it's great. If we can graph it, we can find the solution. Let's look at problem number 2. Let's grab this one. Uh-oh, something wrong with this one. They are not currently both in slope-intercept form. Or actually, neither of them are. So that stinks, because we got to do some work then with them. Alright, so let's actually take them and put them into slope-intercept form. So I've got 2x minus y equals negative 5. So, then we have negative 2x minus y equals negative 1. So I'm going to solve them to put them into slope-intercept form so we can graph them and see where they cross. So right here we have minus 2x on both sides. Let me get rid of that x term. So we have minus y, or minus 1y, equals negative 2x minus 5. Finally get rid of that minus or that negative 1 by dividing by 1. Do that on the other side. So we have y equals negative 2x divided by negative 1 is 2x, so 2 over 1x. Negative 5 over negative 1 would be positive 5. So there's our one equation. Alright, next one. Now we're going to add 2x to both sides. Sorry. Whoops. Add 2x to both sides. It's a negative 2x. Alright, now we still have negative y, or negative 1y, equals 2x. So it's a positive 2x now minus 1. And we divide by 1. Divide by 1 on this side. We have y equals, it's 2 over negative 1, or negative 2 over 1, x. That's negative over negative would be plus 1. So, I'm going to graph the first one in purple, and the second one in red, and we're going to see where they cross. So, y equals 2 over 1 x plus 5. Starting at plus 5. 1, 2, 3, 4, 5. We're going to go up 2 and over 1. 2 and over 1. Actually, I'm going to go back 2 and down 1. Sorry, down 2 and back 1 so we can continue this line. Not the best line there. Sorry about that. But we'll graph the second one in red. Starting at 1. And then we're going to go up 2, 1, 2, and back 1. Because it's a negative run. Up 2, back 1. And there's the equation. And actually with this one, it's great. You can see clearly where they cross. Clearly where that one ordered pair would work. And that is the ordered pair negative 1 and 3. That's our answer. Okay? So if you can graph them, you can see where they cross, and you can solve the system of linear equations. So, we'll do... Well, that's the basic graphing method. Next time we'll learn briefly about what happens if they either don't cross or they're the exact same line. Alright? So that's our first part on solving systems of linear equations by graphing.